topic and very easy topic, and I will explain you in an easy way. Friends, as we all are observe in our surrounding and classroom several things. For example, fan, blackboard, pencil, eraser, sharpener, chair, etc. These all materials are in different states. For example, water is in a liquid state and the bottle is in solid state and the chalk piece is in solid states. So, these all materials are in a different states. Is it right? Yes. So, I hope you all are understand. For example, see, observe here, it is in chalk piece and it is in solid state. When we break down the chalk piece and smash it, observe here, what is going on? Yes, the small tiny particles are falling down. So, these tiny particles are called atom. So, it's look as a simple statement, but it is very difficult to explain. So, I hope you all are understand what's today's my topic. Yes, my topic is structure of atom. The atom is very tiny particle is called as an atom, and the atom consists some particles. They are electron, proton and neutron. These three are called subatomic particles, and the center of the nucleus, the center of the atom, the nucleus is present, and the nucleus consists two particles. They are proton and neutron, and remaining one is electron, that is revolve around the nucleus. So, now we discuss a brief information about these three subatomic particles. Electron. The electron discovered by J.J. Thomson. His full name is Joseph John Thomson. The electron discovered in the year of 1906, and the electron represented by a letter E, and the electron have a negative charge. We denoted the electron as a e to the power of minus because the electron have a negative charge, and the mass of the electron is 9.1 into 10 to the power of minus 31 kg. So, this 9.1 into 10 to the power of minus 31 kg is very less in inverse. So, we call electron as an elementary particle. I will repeat again, friends. The electron discovered by J.J. Thomson in the year of 1906, and the electron we denote as a e to the power of minus, and the electron mass is very less in inverse. So, we call it as an elementary particle. So, friends, this is information about an electron which is revolves around the nucleus. Now, we discuss another subatomic particle, that is an proton. The proton discovered by Goldstein in the year of 1920. The proton represented by a letter P, and the proton have a positive charge. We denote the proton as a P to the power of plus because proton have a positive charge, and their electron we denoting as a e to the power of minus because electron have a negative charge. Here we are denoting to the proton P to the power of plus, and the proton mass is 1.67 into 10 to the power of minus 27 kg, and the proton mass is approximately 1836 times is greater than the electron. So, by this we can say as the proton have a more mass. Is it right? Yes. And the proton mass is equal to the neutron mass. So, this is the information about a proton which is present inside the nucleus. Let me discuss about another subatomic particle, that is an neutron. The neutron discovered by James Chadwick in the year of 1932, and the neutron represented by a letter N, and the neutron is also called as chargeless particle because the neutron not have a positive charge or a negative charge. So, we calling neutron as a chargeless particle, but the neutron mass is approximately equal to the proton mass. So, how much the proton mass? Exactly. The proton mass is 1.67 into 10 to the power of minus 27 kg. So, the proton mass is approximately equal to the neutron mass. So, this is information about a neutron which is present inside the nucleus. Friends, now we discuss about these three subatomic particles, which two are present inside the nucleus and one is revolves around the nucleus. So, now we discuss, friends, many scientists give a different models about on a structure of atom. Today we are going to learn three subatomic particles on a structure of an atom. They are J.J. Thomson atomic model and Rutherford atomic model and Niels Bohr atomic model. So friends, now we discuss about the J.J. Thomson atomic model. The J.J. Thomson atomic model gives a Thomson scientist and he explained the two fundamental particles. They are proton and electron. And he also explained how electrons are arranged within an atom. And he done some activity by using a watermelon. Do you know friends what is a watermelon? Yes, the watermelon is a fruit which is more in summer season. Is it right? Yes. So, the J.J. Thomson was done an experiment by using a fruit that is a watermelon. Now, I am going to do an activity by using a watermelon. How J.J. Thomson was explained to us. So, friends, see here, it is a watermelon. When we cut this watermelon, inside the watermelon, the red part is present and the black seeds are distributing throughout it. Is it right? Observe here, the red part which is present, it is a positive charge, and the which are the black seeds are present, it is a negative charge. So, the J.J. Thomson scientist says us, which is red part, it is a proton, and which are the black seeds are present, it is a neutron. So, red part is a proton and the black seeds are the neutron. So, by this fruit, the J.J. Thomson explained us the atomic model on the structure of an atom. I hope it is very clear to you. So, let me discuss about another atomic model. That is an Rutherford experiment. So, observe here friends, it is a lead box and it is an beam of ray. Observe here friends, it is a lead box and it is a gold foil which is middle of the deflection screen. So, in the lead box the ray is passing and some ray is going to a straight line and they are forming a 180 degrees. Is it right? Yes. And some rays are bouncing back and they are forming a small angles. Is it right? Yes. So, now friends, I am going to do one activity. Are you ready to do activity? So friends, the required materials to activity is rocks and exam pad. So imagine it is an deflection screen and it is an alpha particle ray. When the alpha particle ray is passed to this, some are in a straight direction and some is bouncing back and they are forming a small angles. Is it right? So friends, and this experiment is done by Ernest Rutherford scientist. He was born in New Zealand and he was also called as the father of nuclear physics. And he was also done some experiment by using alpha particle and gold foil. And he also explained how electrons are arranged within an atom. And he got a Nobel Prize in physics in the year of 1908. And the alpha particle means they consist two protons and two neutrons are bound together is called as an alpha particle. And in his activity, the most of the rays are passed to a straight lines to form a 180 degree. But only few rays are reflected back and they form a small angles. So, he done activity by using a alpha particle and gold foil, but in his activity he done some limitations. So now we are going to learn the limitations of Rutherford. So friends, the limitation of Rutherford is it does not explain the stability of an atom. He does not explain the stability of an atom, and he also does not explain the how electrons are arranged in the atom. And he also the electrons are accelerating around the nucleus and they would continuously emit by a electromagnetic radiator and they lost energy. And when the electrons are fall into the nucleus, the atom will be collapsed. Observe here friends, when the nucleus are fall into the atom will be collapsed. So these are the electrons which falls into the nucleus, the atom will be collapsed. So these are the limitations done by the Rutherford. So friends, which are the limitations of Rutherford? The Niels Bohr scientist was clear to it. I hope it is very clear the limitations of the Rutherford. He does not explain the stability of an atom, and he also does not explain the arrangement of electrons. And he says when electrons are fall into the atom will be collapsed. Is it right? Yes. Now we discuss about the Niels Bohr atomic model. The Niels Bohr atomic model, we already know that the electrons are revolved around the nucleus. Is it right? Yes. The electrons are revolved around the nucleus in a particular path. These particular paths are called orbits or shells. So these orbits are named as K, L, M and N. So these K, L, M, N shells are called main shells. And this main shell number represented as 1, 2, 3 and 4. So, and he also explained how electrons are arranged within an atom. And he also explained in different shells how many electrons are occupying place. And the Niels Bohr scientists give us a formula that is 2n square. By based on this formula, we substitute in different shells how many electrons are occupied. So friends, here n equal to 1 and the formula is 2n square. In the place of the n, we have to substitute 1. 2 into 1 square. So, the 1 square is 1. Yes, 2 into 1 is equals to 2. So, in K shell, the maximum 2 electrons are occupied. Is it right? Yes. And now, we substitute n equal to 2. So, in the place of n, we have to substitute 2. The 2 into 2 square. The 2 into 2 square how much? Yes. The 2 into 2 square is 4. 2 into 4 is equal to 8. So, in the L shell, the maximum 8 electrons are occupied. Now, n equal to 3. So, here n equal to 3 and in the place of n we have to substitute 3. So 3 square is 9. In M shell the total 8 electrons are occupied. So in M shell the maximum 18 electrons are occupied. Now the next n equal to 4. In the place of n we have to substitute 4. 2 into 4 square is 16. 2 into 16 is 32. In N shell, the maximum 32 electrons are occupied. So, based on this electron occupying place, we have to distribute the atomic numbers. So, friends, see here, it is in a nucleus. Inside the nucleus, the two subatomic particles are present. they are proton and neutron, and these are the electrons which is revolves around the nucleus. So friends, there is a 4 shells or orbitals. They are K, L, M and N. These are called main shells, and the main shells are number represented as 1, 2, 3 and 4. So in K shell only 2 electrons are occupied. In L shell only 8 electrons are occupying place. In M shell 18 electrons are occupying. In N shell 32 electrons are occupying. So friends, now we distribute the electrons in these orbitals. So friends, here first we take one example, that is an helium. The helium atomic number is 2. So what the atomic number, the electron also same. If the helium atomic number is 2, the electron also 2 are present inside that atomic number. So here first we distribute, see here picture, in K shell 2 electrons are occupying, and in helium they have 2 electrons. So here 2 electrons are distributing. And now we take another example, that is a neon. So what is the atomic number of neon? S. The atomic number of neon is 10. So now only we discuss the K shell occupy 2 electrons and the L shell occupy 8 electrons. So the neon atomic number is 10. So in K shell only 2 electrons are occupied, and in L shell 8 electrons are occupied. So here first we distribute 2 electrons on a K shell and remaining 8 is there. They will be distributed in a L shell. So 8 plus 2, 10. So the atomic number of neon is 10. Here 10 electrons are distributing. So friends, like this, like based on this formula, the Niels Bohr was explained as how electrons are distributing in a orbitals, and the K shell is called lowest energy level, or it's also called ground energy level, and this N shell is also called highest energy level, and it's also called existence energy level. So the K is called lowest energy level and the N is called highest energy level. So friends, I hope it's very clear about a Niels Bohr atomic model. Let me summarize what we have learnt. The atom is a smallest tiny particle is called as an atom, and the atom consists some particles. They are proton, electron and neutron. These proton, electron and neutron are called subatomic particles. And we have also discussed the all materials are made up of tiny particles, and we discussed the 3 subatomic models. They are Rutherford atomic model, J.J. Thomson atomic model and Niels Bohr atomic model. So friends, the J.J. Thomson atomic model is commonly called watermelon model, and it's also called plum pudding model. And the J.J. Thomson was says as which is red part is present, it is an proton, and which are the black seeds are present, it is an electron. The red part is an proton and the black seeds are neutron. So like this, by using watermelon, he explained as which is proton and which is a neutron. And let me know about Rutherford atomic model. Rutherford atomic model was done by the Rutherford scientist, and he done by using of alpha particle and gold foil. And the alpha particles means 2 proton and 2 electrons are called alpha particle. And Niels Bohr atomic model, he gave us a formula that is an 2n square. Based on this formula, we have to substitute in different shells how many electrons are occupying place. My conclusion is, I concluded that all matters are made up of tiny particles and the atom is divisible. Atom consists 3 subatomic particles. They are electron, proton and neutron. The electron, proton and neutron are subatomic particles and the proton and neutron are present inside the nucleus. And the electron is revolved around the nucleus. And the electron is also called elementary particle. And the proton have a more mass when we compare to the another 2 electrons. And the neutron is also called chargeless particle because it no have charge, either positive or negative. A pleasant evening to all. A thankful to everyone to giving me this golden opportunity. A thank you to Secretary Sir and Regional Coordinator P.S. Kalyani Madam and my Principal Rajeshwari Madam and my Vice Principal Shravanti Madam, and at the last but not the least to my mentor teacher Saraswati Madam, and I thankful to everyone, and I especially thankful to Telangana government and TSAT channel, and thank you to everyone. Thank you so much to support me and a well on a screen. Thank you to everyone. Happy learning.